Hello everyone, we are going to begin our unit on primarily parallel lines and angle relationships that are formed with them, but we're also going to talk a decent amount about perpendicular lines as well. So today we are going to start with some kind of background information that's mostly vocabulary, and we're going to identify pairs of lines and angles. And so today's purpose is to be able to name, identify, and draw relationships for lines and angles. So just as a quick reminder, remember that two lines are parallel if they do not intersect, and they are coplanar. So they lie on the same plane, but they never cross one another. And two lines are skew if they do not intersect and are non-coplanar. Okay, and then two planes that don't intersect are just called parallel planes. So two planes that don't intersect are called parallel planes. So that'd be like the floor and the ceiling. So, okay, a little bit more about parallel and perpendicular lines. So we have a couple of postulates that you're going to use more in application rather than like proofs, but they're still important because we come across this quite a bit. So the first one is the parallel postulate, and it says if there is a line and a point not on the line. Okay, so let's just go ahead and draw it. If we have a line and a point not on the line, then the postulate says there's exactly one line through that point that's parallel to the other line. Okay, so there's only, how many lines can I draw that pass through this point and are parallel to that one line? And the answer is one, and that's what the postulate is saying. Okay, so if this was line L and this was line M and this is point P, okay, we can say in our notation that if P is not on line L, then only line M can go through P, okay? So, or can include P and be parallel to line L. All right, so that notation is really just another, like, it's just a specific example to the postulate. So the perpendicular postulate says the same thing. If you have a line and a point that's not on the line, then there's only one line that we can draw that goes through the point and is perpendicular to the given line. So again, if we have line L and line M and a given point P, if P is not on line L, then line M is the only line that can contain P and be perpendicular to L. Okay. All right, so like I said, you're going to apply those two postulates. They're not going to be postulates that will likely show up in a proof or anything along those lines. But anytime that we're drawing a line to another line so that it's perpendicular through a point, you're really just applying that postulate. Okay, this also defines the distance from a point to a line. So if I want to know the distance from this point to this line, it's got to be on the line that's perpendicular to it.